Good morning, guys. Today we're going to be going over 5.4, solving rational exponents and also radicals. The examples you need to know are 1, 3, 4, 5, and 6. We're going to go over every example in order. Solving by example 1. First of all, they give me this first example. 2x plus 1 equals 4. That is example 1a. Now, all you want to do is isolate until you're left with a radical on one side. Doesn't matter how many elements are inside the radical. You want to just get rid of everything except the radical. So in this case, I'm going to be dividing by 2. And I'll have x plus 1 equals 2. Now, when you have a radical, you're going to raise that side to the power of the radical. So since it's 2, I'm going to square it. And I'm also going to square everything on the right-hand side. This square gets rid of this radical, and I have x plus 1 equals 4. Minus 1, x equals 3. That is example 1a. Get rid of everything except the radical, raise the exponent to the power of the root on both sides, and then solve. Pretty straightforward. You've already done this multiple times. Let's go over b. Now I have a cube. 2x minus 9 minus 1 equals 2. In this case, we want to work like reverse PEMDAS. Remember, we want to get rid of the things that are farther away from my radical. So we first get rid of this 1, and I have cube root of 2x minus 9 equals 3. Now I raise this side to the third power. I raise everything on the right-hand side to the third power. This cancels my root, and I have 2x minus 9 equals 27. Plus 9 plus 9, 2x equals 36, divided by 2, x equals 18. Done. That's example 1. Pretty straightforward. And it's just solving radical equations. Now let's go over the example 3. Again, you can jump example 2. In example 3, they're telling me solving an equation with an extraneous solution. So they tell me that x plus 1 equals radical 7 x plus 15. Now note, let me just write this down a little bit better. Note that in this case, in the previous case, I just had a single x. Now I have two x's, and one of them is in the radical. So again, first of all, step 1, get rid of your radical. When you're looking at something that looks like example 3, you got to get rid of your radical. How do you get rid of your radical? Again, we raise both sides to the power of the root. This cancels this. Now, please remember, I've told you guys a billion times, and students still keep doing this mistake. X plus 1 squared is not x squared plus 1 squared. Please do not do this. If you do FOIL, or top to bottom multiplication, again, you're multiplying that by itself. 1 times 1 is 1. 1 times x is x. X times 1 is x. X times x is x squared. When you add everything, you're left with x squared plus x plus 1. Many students forget the middle portion that comes when you multiply those two elements. So please multiply correctly. Also, if you want to learn a little, like rule, this could be a, this could be b. When you expand a binomial to the second power, it's a squared plus 2ab plus b squared. And this is 2x. See, I did this when I added the two x's, it had to be 2x. When I looked at my formula, which is what I always use, I realized that there was a mistake. I use this formula. Square this, 2 times the first plus square of the first plus square of the second plus 2 times the first times the second. There you go. Square of the first, square of the second, times 2 times the first times the second. So again, this is what I get when I expand this binomial, and this side is equal to now this side without the radical because I canceled it out. 7x plus 15. Now remember, when we have multiple x's, I'm going to send everything to the left-hand side. I could send everything to the right-hand side, but my leading term would be negative, and it's always easier to work with a positive leading term. So I always send the elements to where the leading term is. So minus 7x minus 15, when I move it here, and I combine my like terms, I have this after you combine everything. And guess what we do now to find the solutions? Factoring. Again, this is standard form. Two numbers that multiplied give you this and added give you this. Negative 7 plus 2. X minus 7 and x plus 2. When you multiply those two, you get negative 14. When you add those two, you get negative 5. Now, when you have multiple solutions, like in this case, you have to check for the solutions to make sure they're not extraneous solutions. Let's try with the first solution, which would be 7. Remember, the solutions are the numbers you plug in here to get 0. So let's try with 7. And let's plug the 7 in the original equation. 7 times 7, 49, plus 15, 64. Square root of 64 is 8 on the right-hand side. And on the left-hand side, 7 plus 1 is 8. So the 7 checks out. 7 is a solution. Let's check for my negative 2. Negative 2 times 7, negative 14, plus 15, square root of let's begin. Negative 2 times 7, negative 14, plus 15, 1. Square root of 1 is 1. So I have 1 on the right-hand side. And negative 2 plus 1 is negative 1. Remember, this square, I actually added that square at the end. That doesn't count. It's just x plus 1 equals the radical. Negative 1 is not equal to 1. So the negative 2 here is not a solution. The only solution is 7. When you have multiple solutions, you have to plug them in and confirm that they are solutions unless I specify otherwise. That is example 3. Again, square both sides, properly expand the binomial, send everything on the left-hand side and join like terms, and solve. Sometimes you'll have to solve by greatest common factor. Sometimes you have to solve by factoring. Sometimes you have to solve by just simplifying. Just solve it using the tools that you know. That is example 3. Let's go over example 4. Okay, now here's where it starts getting a little tricky. Example 4, again, I do need you guys to pay attention on this one right here, because this one starts to get tricky here. Here's where students start having a problem. And I'm going to explain. You might have to watch this part of the video 2 or 3 times. That's fine. Watch it as many times as you need to understand the process. It's the whole point of the video. Profe, can you explain again? Boop, rewind. Problem solved. Okay, now you can see here, you can see that I have radicals on both sides. And if I did not have this one, it would be pretty easy. Because again, you just square both sides, get rid of the radicals, and solve. Actually, let's try one like that so you guys can see. If I had this, for example, I could just square this side, cancel my radicals, have this, send the x this way, send the 7 this way, and that would be the solution. Pretty straightforward. The problem is with this 1 that they're adding on one side. Every time you see, I'm dropping everything. Every time Where's the eraser? Sorry about that. Mini whiteboard. Every time you see two radicals and a number that is added or subtracted from one side, or a variable, just an element added on one side or the other, it complicates things, and you'll see why. First of all, like I did in the bottom, I have to square both sides. So I'm going to square the right-hand side, and I am going to square the right-hand side. Not just the radical, but the right-hand side, including that +1 that is outside of my radical. On the right-hand side, it's pretty straightforward. This gets canceled out, and I'm left with 3 minus x on the right-hand side. Pretty simple. But let's see what happens when we square this expression. Again, please do not do FOIL, top to bottom multiplication, or the rule that I showed you guys. I'm going to do top to bottom multiplication. So since I'm squaring it, I have x plus 2 plus 1 times itself. Let me actually write this up here because I'm going to need more room. So again, I'm going to multiply these two. I'm going to multiply these two because I'm squaring my right-hand side. Let's begin. 1 times 1 is 1. 1 times the radical is the radical. That takes care of my 1. Now let's go over the radical. The radical times 1 is the exact same radical. And again, you're always going to end up with this sort of expression. And now let's think. When you multiply the radical times itself, when you multiply a number by itself, it's pretty much the number squared. The same thing applies to the radical. So when I multiply the radical by itself, I end up with an expression that looks like this. The radical squared. The radical times itself when I multiply these two. Since it's the radical squared, the square cancels out the radical, and you're left with x plus 2. Okay, now what do? Add everything. So I'm gonna just write my answer here on the right-hand side. X plus nothing is x plus 2. This is a plus here. Let me go over the radical first. Plus 2 radical x plus 2. Why 2 radical x plus 2? Because again, think of this as a variable. It's an identical radical. X plus x is 2x. Square root of x plus 2 plus square root of x plus 2 equals 2 square root of x plus 2. And this 2 that came from the multiplication of this times this, and the 1 that is here on the right hand side gets added, and that turns into a 3. So again, let me repeat the addition so you can see it clearly. After I multiplied, I ended up with this. And then after I got rid of the radical, I ended up with this. Okay. This 1 and this 2 added to form a 3. These two added to form 2 square root of x plus 2, and this exits by itself. Okay. Now what do? I'm going to send everything to the right-hand side. To leave only this radical here. So I'm going to get rid of the 3, minus 3, it cancels out, nice and neat. I'm going to send the x this way, minus x. So currently I have 2 square root of x plus 2 equals negative 2x. That's what I'm looking at right now. Now I'm going to divide by 2. I have x plus 2 equals negative x. Now what am I going to do? Square a second time. I'm going to square the left-hand side, square the right-hand side. This cancels this. And I have negative x squared. X plus 2 equals negative x squared. Since I want the leading term to be negative, I'm going to send it to the left-hand side, and I'm left with the following expression. Plus x squared plus x plus 2 equals 0. I'm going to factor that. Two numbers that multiplied give you this, and added give you this. Oh, there was a mistake. Sí, no me estaba dando. When I squared, I had negative x here. I had negative x here. When I squared the negative x, it turned positive. I apologize for that. The negative x turned positive. So instead of sending this element to the left, I send these two to the right. I apologize. So when I send them to the right, I end up with this expression, which now it makes sense because I looked at that factoring and I'm like, okay, this doesn't, has no solution. In the book, it has a solution. Now I end up with this expression because again, since the leading term is positive, I'm going to send these two over to it so it stays positive. And I end up with this expression. Now, when I look at that expression, I am going to factor. Again, yay, we love factoring. Two numbers that multiply give me this, and added give me this. Negative 2 and 1. So I'm going to have x minus 2, x plus 1 equals 0. So my solutions, which I don't know which ones are correct yet, are 2 and negative 1. What do I do then? Plug those numbers into the equation and check to see if they are actual solutions or not. But you're going to do that. Now, again, that was example 4, which is the trickiest example. So remember, we square both sides. One side, the radical goes away. The other side is a binomial that needs to be expanded properly. After you expand that binomial properly, you're going to isolate everything to the other side until you're left with a radical on the left-hand side. After you're left with the radical, you're going to square both sides again to get rid of the remaining radical. Then you're going to solve normally. You might have to watch this process a couple of times. Make sure you do it because, again, this is probably the trickiest class in a while. So make sure you do it properly. That was example 4. Now let's go over example 5. In example 5, it's solving an equation with a rational exponent. I have 2x. Now guys, here you have to be very careful with your parentheses, okay? Plus 2 equals 10. I have this expression. Profe, what the heck do I do now? Well, there's a couple of things you can do. You could turn it into a radical if you're comfortable working with radicals, or you can just work with rational exponents, which is what I recommend. You'll see why. So first of all, what do we do here? Step 1, isolate everything until you're left with the expression with the variable. So minus 2, minus 2. I have 2x, and this is raised to the 3/4 equals 8. Now here's the tricky part. And it's not that tricky. This is just the part you have to do. I want to isolate my x now. So I have to get rid of this exponent. Since I'm looking at an exponent that is 3/4, let's think. What were to happen if I were to multiply by its reciprocal? What is 3/4 times 4/3? Everything cancels out and you're left with a 1, which is what you want to have. So what you do is you multiply, and again, this is the exact same process. You always multiply both sides by the reciprocal of the power you're given. If I multiply this to the 4/3, this turns into an exponent of 1, which is what you want. But then you also have to multiply the other side by the same power. And if you were to remember, now you have to think and turn this into a radical so you can work with this. This was the first class of this chapter, turning rational exponents into radicals. So on the side, let me turn this into a radical. Remember, the number at the bottom, the denominator, becomes the power of the root, and the numerator becomes an exponent. What is the cube root of 8? 2. Because 2 times 2 is 4, times 2 is 8. So the cube root of 8 is 2. And 2 to the 4th power is 2 times 2, 4 times 2, 8 times 2, 16. So I'm left with the following expression. Isolate, and there you have your solution. So again, let me repeat. You were given a fractional exponent. You multiply by the reciprocal, so it turns into a 1. You isolate the rest, and you also multiply the right-hand side by the reciprocated exponent. You solve the reciprocated exponent, which in this case gave me an actually nice number, and then you just isolate and solve normally. That was example 5. Now let's look at the final example. We're not going to go over radical inequalities today. Now we have this. Let me actually write it a little bit up top. I have x plus 30 to the 1/2 equals x. Again, same thing applies here. Rational exponent multiplied by the reciprocal, 2 over 1, which is 2. So I'm going to square this side, I'm going to square this side, and I'm going to square the right-hand side. This turns into a 1, so I have x plus 30 equals x squared. Now I send everything to the left-hand side. Minus x minus 30, minus x minus 30. Standard form. Two numbers that multiplied give you negative 30, added give you negative x. Minus 6 plus 5. Multiplied negative 30, added negative 1. Then what do? You plug in the numbers and verify. That's it for the class. Now for homework, I need you to do from 3 to 8, 15, 16, 17, 21, 22. Again, today is going to be slightly longer than usual, but you do have to practice this because it's very, very tricky. 27, 28, 29, 30. That's the homework. Now, if you have questions today, I'll try to explain via voice note, or you can just write the ones that give you problems and we can go over them all on Friday. Now, one thing to keep in mind, remember, everyone's uploading their homework. If you have questions, you can actually review other people's homework, see how they work, see if you got the right answer, different answer. If you got a different answer, you can contact me or contact your friends and discuss. Again, the whole point of this process is to have you guys upload your homework and also be able to discuss amongst yourselves how you guys are working. Try to be a little self-sufficient. And again, you can always count on me, but you gotta start relying on yourself as much as possible. Okay. That's it for today's class. Make sure you practice. Send the homework before 10. Good job. See you soon.